So today I'm going to show you one example of how to transform a power function. So let's say, for example, I give you this equation, y equals 2 times the quantity 1/2 x minus 1 squared plus 3. So there's many different ways I could graph this by hand, but I find the easiest way is just to find 3 good points on the parent function and then do the transformations. So the parent function for this example is y equals x squared. Now you want to pick some good points so that when you do the transformations you know what the graph looks like. And I find the 3 good points are 0, 0, mainly because 0, 0 is the vertex. It also shows where the graph changes from decreasing to increasing. And then 2 other points are 1, 1 and 2, 4. So the first step I'm going to do is I'm going to do all the steps that affect the input values. So inside the parentheses, what I've highlighted, 1/2 x minus 1, affect input values. Now, you do everything backwards inside the parentheses. It's really strange. So instead of multiplying by 1/2 and then subtracting 1 from my x values, I have to do it backwards. Just think about solving for x. So if I were looking at 1/2 x minus 1 and solving for x, I would first add 1 and then I'd multiply by 2. So that's what we're going to do to each one of our x values. So the first step through, I'm adding 1. And then the second step is I'm multiplying every single x value by 2. So now I have some new points. We're not done yet. We still have 2 more transformations. The ones on the outside of the parentheses affect the output values or the y values. And these are done in order of operation. It's not backwards. So I'm going to multiply first and then add. So to each one of my y values, I'm multiplying by 2, and then I'll add 3. So the point 0, 0 has now become the point 2, 3. And the point 1, 1 after the transformation is now the point 4, 5. And the point 2, 4 is now the point 6, 11. And you know where the vertex is, and you can graph your new function. And now I have to answer the phone.